Hello and welcome to yet another South Korean college scholastic ability test video. Today we are going to solve the following problem. What is the range of x satisfying the following system of inequalities? So the first inequality is 7 minus x is greater than or equal to 3 times the absolute value of x minus 3. So let's call this inequality number 1. And the second inequality is 1 over x minus 1 plus 1 over x minus 3 is greater than or equal to 0. So let's call this inequality number 2. First, let's solve inequality number 1. Since this inequality contains absolute value notation, we need case division. First, when x is greater than or equal to 3, the inequality becomes 7 minus x is greater than or equal to 3 times just x minus 3. So 7 minus x is greater than or equal to 3x minus 9. So 16 is greater than or equal to 4x. So x is less than or equal to 4. Since we also have the condition x is greater than or equal to 3, we need to find the common range between these two, which gives x is greater than or equal to 3 and less than or equal to 4. Next, when x is less than 3, then we have 7 minus x is greater than or equal to minus 3 times x minus 3. So 7 minus x is greater than or equal to minus 3x plus 9. So 2x is greater than or equal to 2, which gives x is greater than or equal to 1. So common range between this and x is less than 3 is x is greater than or equal to 1 and less than 3. The solution to inequality 1 is the union of these two, which is x is greater than or equal to 1 and less than or equal to 4. Let's call this range 1 prime. Next, we move on to inequality number 2, the fractional inequality. Reducing to the common denominator x minus 1, x minus 3, we have x minus 3 plus x minus 1 at the numerator, which gives 2 times x minus 2 divided by x minus 1, x minus 3 is greater than or equal to 0. Here, this 2 can be cancelled out since we can divide both sides with 2. But we must be careful when trying to remove the fraction. The first instinct is that we multiply x minus 1 times x minus 3 on both sides. But since x minus 1 times x minus 3 can have both positive and negative values, we cannot do that because when it comes to inequalities, if we multiply negative numbers on both sides, the direction of the inequality must change. The method we can use in this situation is as follows. We don't need to care about the direction of the inequality if we only multiply positive values. Therefore, instead of x minus 1 times x minus 3, we multiply x minus 1 squared times x minus 3 squared, which stays positive all the time. The catch here is that it becomes 0 when x equals 1 or x equals 3, but in this case, x cannot have the values 1 and 3 because they make the denominator 0. So by multiplying this, the inequality becomes x minus 1 times x minus 2 times x minus 3 is greater than or equal to 0. And it is a good practice to indicate the additional condition that x cannot have the values that make the denominator 0. So now we have the cubic inequality, which can be solved by drawing the graph of y equals x minus 1, x minus 2, x minus 3, which passes 1, 0, 2, 0, and 3, 0. So the function has non-negative values in these ranges, and considering that we also have to exclude 1 and 3, we obtain the range x is greater than 1 and less than or equal to 2, and x is greater than 3. Let's call this range 2 prime. The solution to the given system of inequalities is the common range between 1 prime and 2 prime, which is x is greater than 1 and less than or equal to 2, and x is greater than 3 and less than or equal to 4. Therefore, the correct choice is choice 5. And that's all for today's video. Thank you for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.